we're going to explore here, okay? And so let's take a look at world-class sprinters can run 100 meters in under 10 seconds. Okay, so here's some recent results of the men's 100-meter sprint times. Now, some of these are a little more recent than others. Other ones are quite a while ago. But we have three guys here. We have a guy by the name of Usain Bolt. May or may not have heard of him. Is the fastest man in the world, at least at the time of this video, as far as I know. He can run 100 meters in 9.58 seconds. Another guy by the name of Asaf Powell, okay, can run in 9.72 seconds. And this guy here, Donovan Bailey, ran it in 9.84 seconds. Now, for those of you that have not heard of him, okay, this guy right here, and we're going to draw a little maple leaf. He is a Canadian, yeah. Okay, Donovan Bailey is a Canadian. He was a world record holder for a time when he ran the 100-meter dash in 9.84 seconds back in 1996. Which you don't remember. I was alive. I was, a young child at the time. Middle-ish age child. A little younger than you are right now. But I remember watching him and breaking the record, and it was pretty special for us as Canadians. But let's figure out, okay, so let's just take a look at some of these here. And we're going to take a look at how we come up with rates in a little bit as well. But let's say that we're going to make a graph that's going to use Usain Bolt and Donovan Bailey. And they're going to run a 500-meter race, assuming they can run at exactly this speed right here. So let's come up with a little table of values, and then we're going to graph this out. So Usain Bolt in 100 meters would run it in 9.58 seconds, and Donovan Bailey would be 9.84 seconds. Now you can probably kind of guess how we find the rest of them. If we can keep doing that, okay, so Usain Bolt, if we multiply it by 2, we could assume that if he could run the same pace, he would run that in 200 meters in 19.16 seconds, or 100 times 2, right? What do you in 100 meters? Multiplied by 2. Okay, and in 300 meters, it would be at 28.74 seconds. 400 meters would be 38.32 seconds. And 500 meters would be in 47.90 seconds. And now you don't necessarily have to write the 0, but I often do. Donovan Bailey, on the other hand, runs a little bit slower, right? So time-wise is a little bit slower here. So we have 9.84 times 2, and so this is 19.68 seconds. And now again, we're always going to add the same amount. 52 seconds plus 9.584, 39.36 seconds, and finally 49.20 seconds. All right, so if we were to do a 500-meter race, Usain Bolt, again, based on if he could keep this pace going the entire time, which is pretty impossible, actually, especially longer the distance tends to go a little slower. If any of you are runners, you really understand that. So Usain Bolt, it would take him 47.9 seconds, and Donovan Bailey 49.2 seconds. Now let's create a little graph and show how we can see what it looks like on the graph. X is always going to be, this is a distance time graph, and so X is always going to be our time, and Y is always going to be our distance. And I'm going to start with 0 right here. Distance, we need to get to 500 meters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Look at this. What I can do is every 3. So 100 meters, 200 meters, 300 meters, 400 meters, and 500 meters. Let's try to maximize this graph as much as possible. Same thing on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so we want to get up to 50 seconds. So let's do every 3 is 10 seconds. And so this is 20 seconds, 30 seconds, 40 seconds. I'm just trying to maximize the graph here as much as possible. And we could put here, these are going to be seconds, and this is going to be in meters. Okay, just to describe it a little bit. And this is a speed graph or time graph. Now, if we were to graph out let's do Usain Bolt. He starts at 0 here. At 100 meters, he's at 9.58 seconds. So that's going to be right about, let's see, it's going to be right about there. And now these guys are going to be pretty close to start. And then if we keep going, I'm going to actually do it a little simpler. I'm just going to go to the end. And at 50 seconds, at 500 meters, he is at 47.9 seconds. So that's going to be right about there. And this is going to be our line right there. Okay, now based on linear functions, we should know that these are going to be our points that we're dealing with. Okay, so if we look at 400 meters, 38 point, so that would be roughly about 38.32, roughly, based on that. Don Bailey, on the other hand, we're going to do this one in red. Okay, 500 meters, it takes him 49.2, so 49.2 will be right over here. And he started at 0 as well. And so that's going to be his line. You'll notice that it is slightly different than Bolt's. Okay? It has a slightly different slope. Now, the slope, okay, represents how fast they're going, and that is a distance over time. Rise, change in distance, over run, change in time. Okay? And so someone like Usain Bolt, okay, and we're going to put this in as a rate, can run 500 meters, and this will be Bolt, in 47.90 seconds. Okay, that's a rate. And if we simplify that, we get 500 divided by 47.9 to be 10.44 meters per second. Okay, or he can run 10.44 meters per second. Now, I'd like to give this example in class because in class, our classroom is roughly about 10 meters long. And this just says that he can run our class length every second. That's fast. So about every time that you snap your fingers like this, he can run across the class. And Bailey, we can assume, will probably be a little bit slower. Okay, he runs the 500 meters in 49.20 seconds. Or, if we do the calculations here, 49.2, it is 10.16 meters per second. So he can't run quite as far. Bolt can run a little bit farther every second than Bailey can. Okay, it's because he's going a little bit faster. Okay, the slopes are exactly the same thing. The slopes, okay, remember it's rise over run. And so this is the change in distance, which is our y, over the change in time, which is our x. Okay, at distance over time equals, let's move this up a little bit here, distance over time equals speed. So if we have a distance over time graph, that's speed. For those of you that are in physics, you understand this as a displacement over time graph, which will represent velocity. We're only going to deal with speed in this case here, and speed is just positives. It doesn't matter if you went forward or backwards. It's just we're just going to deal with a positive speed, so it's whatever the slope of that graph is. Okay. We could do the same thing with Asaf Powell if we wanted to as well. We could find find his speed there as well.